We're going to start section 6.1, which is about set theory. So let's start with a definition. Let's define a set. A set is a collection of objects called elements. So for example, let's say S is the collection of 1, 2, and 3. So I would say S is a set whose elements are 1, 2, and 3. So as you kind of saw, the notation that we use for a set, the notation is curly braces, and we can use the notation that we've used previously, collection of X and S, such that P of X. So now that we know what a set is, let's talk about what subsets are. So we're going to define subsets, and the notation that gets used here is it's almost like a less than sign, but it's kind of a curved. A is contained in B. So we would say A is a subset of B if and only if for all X, if X is in A, then X is in B. So basically every element of A has to be an element of B as well. So what we're going to do is we're going to take this statement right here and we're going to look at the negation to see what it means to not be a subset. So we would say A is not a subset. You use a line through. A is not a subset of B if and only if. Negate the for all. There exists an X such that, and then you have to remember how to negate these conditional statements. So the negation would be X is in A and X is not in B. So there's an element of A that is not in B. And we're going to write one more definition down, and it's for a proper subset. So we would say A is a proper subset of B if and only if two things have to happen. First, A needs to be a subset of B, and the second condition is that there is at least one element in B that is not in A. So B, in some way you can think of it as being larger. It has an element that's not in A. Alright, so let's look at our example here. Let's let A be the set containing the element 1 and B be the set containing 1 and 2. And the first thing I want to ask is A contained a subset of B? Is A a subset of B? Well, let's look at the elements in A. What are the elements in A? A has only one element, namely, the element is 1. Is this also an element of B? And the answer is yes, it's also an element of B. This is also an element of B. So, every element of A, there's only one of them, is also an element of B. So my answer is yes, it is a subset. So every element of A is in B. Therefore, A is a subset of B. Okay, so now let's ask, is A a proper subset of B? Well, there's two conditions to be a proper subset, and the first one is it needs to be a subset. So from A, we know that A is a subset of B. So our first condition, we have that. Now let's look at our second condition from a proper subset. So if you go back to the definition, we need an element of B that's not an element of A. So let's look. B has two elements, which are 1 and 2. 2 is not an element of A, hence 2 is not an element of A. There is an element in B that is not an A. So that second condition in the definition of a proper subset is met. And so I can conclude, therefore, A is a proper subset of B.